Okay, let's go ahead and continue on with the sequence stuff. So example 5, a sequence is defined recursively. So this means the first or few terms are provided, and the nth term is determined by a rule involving one or more of the previous terms. So in order to get the next term, you need to know the term before it. So let's do part A. So your first term is 2, and then here's your nth term. So basically, to get the next term, you're just adding 3. That's all this is saying. So A2, you're just going to take 3 and then add it to A1. So that would have to be 5. A3, you're going to take 3 and add it to A2. So that would be 8. So you just keep adding 3 to give you the next term. But we want the next 5 terms, so we've got to get 3 more terms out of this. So A4 would be 11, A5, 14, and A6 would be 17. So pretty simple. I'll let you guys look at part B on the notes. But let's get into summations. So summations are kind of nifty because they're just taking like the terms of a sequence and they're just going to add them up to get a grand total. So here's how they're going to work. So they're going to give you like an nth term in there, and then at the bottom they'll say like k equals 1, k equals 2, k equals 7, and then at the top they're going to have another number up here. So this is the first number you plug in down here at the bottom, and then the top number is the last number you plug in. So you're going to start by plugging in the k equals 1 and just figure out what it is. So 2 times 1 is 2, plus 3 is 5. Then you're going to take k equals 2 and plug that in there. So if I plugged in 2 for k, I get 7. And you're going to keep doing that, so plug in 3 and then go all the way up, and then the last number you plug in is 5. So if I plug in the 3, I get 9. Plug in the 4, we get 11. And if I plug in the 5, I get 13. So these would be like the terms of your sequence, but it's a sum. So I'm going to take each of those and add them all together. And then just total it up. So that would be 45. And so that's how the sums are going to work. So let's try these next few. So I squared from I equals 3 to 6. So start with 3. Plug it in. Plug in 4, 5, and 6. So totals 86. Okay. For this one, now you're going to plug in the 0. So 5 to the 0 is 1. 1 plus 1 is 2. Plug in n equals 1. So you end up with 6. Whoops. Plug in n equals 2. 26. And then plug in the top number, the last number, and n equals 3. 126. So we get 160. All right, these next 3 are a little bit different because the stopping number isn't an actual value. So for D, we're going from 1 to n. So just start by plugging in 1, plug in 2, and then plug in 3. So get 3 terms out of this, and then you're going to go plus dot 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 plus, and then you're going to plug the n in for k. In this case, it would just be n. And you would just leave it like this because you don't know what n is, so you don't know like, well, where are you stopping? So you just kind of leave it out like that. Now, sometimes instead of an n, it gives you infinity. So all that's going to do is just going to add something at the end of this. So you still plug in the 1, plug in 2, plug in 3, and then plus dot 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 plus, plug in an n. But the infinity means it's going to keep going. It's not going to stop there. So then you would just do plus dot dot dot. Oh, there's little typos in there. That should have been an N. And that should have been an N. And that should have been an N. All right. Whoops. No matter how many times you edit, there's always something else. Okay, so if we did this something similar with that, plug in n equals 0, and you get 1. Plug in n equals 1, and you get x. N equals 2. 1/2 x squared. So there's your 3 terms. So then plus dot 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 plus plug in n, x to the n over n factorial plus dot dot dot. And there you go. Okay, in the next video, we'll go backwards. So we'll see how to take a sum and express it using the notation.